Okay, so that was a one-day problem. So now, how about this? We're going to move forward and try a two-day problem. So suppose that we are now facing 2 days. So if that's 2 days, then the decision, of course, is going to be more complicated. In particular, today we need to decide whether we want to produce a lot to be used for tomorrow. Okay, so for some reason, let's call the timeline as today we're in the second day and tomorrow is the first day. All right, now this is somewhat because in the previous slides, when we have only one day, we solve the one-day problem with the first day as the last day. All right, so we're going to call today as the second day and tomorrow as our first day. So the problem for the first day actually has been solved. For solved, basically we mean given any possible y1 for tomorrow, I know what to do. I know what's the optimal response to the possible y1 that I may see for tomorrow morning. Alright, so now we're going to focus on this particular time stage. We're going to try to solve y2, which is here. So, given y2, we're going to solve for x2. So we have y2 units on hand at this moment. We need to decide what's our production quantity for day 2, which is x2. Okay, and again, we have that production cost and we have our demand D2 to be satisfied. And the inventory cost is again H. The thing is that now, instead of what we did for period 1, for period 2, there's one thing that is quite different, is that now ending inventory actually creates some values. Why we want to emphasize on this thing? Let's go back to the previous slides to take a look. In our previous slides, we can see that we do have our objective function here, okay? Every day, if we want to produce anything, that's going to create some cost. No one likes cost. So if possible, we want to minimize the production quantity. And for the last day, if we produce something, that's going to add to our ending inventory. So for the last day, there is really no reason to produce too many, okay? We will produce merely what we need. But for second day, the second day is here, okay? For the second day, if we have ending inventory, we know it's going to create some values. Why is that? If we left more for tomorrow, then for tomorrow we may produce fewer. So that's the reason that we have some value for our ending inventory. Okay? So as we say here, the ending inventory, which is y2 plus x2 minus d2, this amount can be used as the initial inventory for the first period, which is going to help us reduce the total cost for that period. Okay? And what's even better is that for the first period, that particular cost is actually given. It's something that we know how to calculate. That is V1 of the so-called Y1, which is Y2 plus X2 minus D2. Okay? Previously, we mentioned to you that here, if we have V1 of Y1, that means given Y1 as our initial inventory for period 1, that's the total amount of cost I need to pay for that particular period if we do the optimal decision. Okay, so here, given all of this, we know that Y2 plus X2 minus D2 is going to be our ending inventory for period 1, and then we know how much to pay for period 1. So collectively, we may say our problem structure is the following. I'm going to consider the decision of deciding x2, and I know x2 is going to have some impact to my x1. Basically, if x2 is larger, I know x1 somehow can be smaller, and the other way. Okay, so we know the two things are connected. What we want to solve for the second period has something to do with the first period. And how may we formulate that connection? Oh, let's take a look. I'm going to choose x2. And again, there's nothing I may use to fulfill today's demand. So x2 must be large enough. It's going to be d2 minus y2 plus as the minimum quantity. So given x2 must be that amount, I'm going to have this one as the production cost for today, this one as my ending inventory cost for today, and whatever amount I have for tomorrow, that's going to generate some cost for V1. And in that case, to solve the problem for the second period, which is today, I need to calculate the cost for the first period given any possible inventory, initial inventory, okay? And that means I need to know if I leave 1 unit for tomorrow, how much I need to pay for tomorrow. If I leave 2 units for tomorrow, how much I need to pay for tomorrow, and so on and so on and so on. I know I'm going to face some kind of trade-off. If today I produce more, then the first part, today's cost, is going to be higher. But the second part for tomorrow's cost is going to be lower. So somehow my mathematical program should find the best balance between today's cost and tomorrow's cost. Okay? Also, that's the idea. And then here, what we want to do is that I want to make some production for this particular period. And basically, all we need to know is that I'm going to leave something for tomorrow. And whatever thing I see for tomorrow morning, I'm going to act optimally in that future first period, given any starting condition. Okay? We know we're going to do that. And we also know that particular V1 function. We know that V1 function under our optimal decisions. So if we have solved the problem for period 1 and obtained that valuable V1, then evaluating our optimal decision for period 2 is going to be simple because we just need to have the trade-off between today and tomorrow. Okay? So that's the idea. When we have 2 days, we're going to have the whatever we have for first day and whatever we have for today. And probably the most important concept here is that we do not need to know what to do in the first period. Okay? Take a look at this formulation again. In this particular formulation, we need to have some information for tomorrow, which is V1. We need to know for some amount I leave for tomorrow, what will be the resulting cost. But I do not need to know what I should do for the future periods. I know somehow tomorrow I will do the best thing. Somehow that's going to create a cost for me. I'm going to leave that decision for tomorrow. Today, I will just focus on what I should do for today. And as long as I know the consequence for tomorrow, then I can make my optimal decision for today.